All right, let's apply the inverse function theorem. So step one here is, what's the inverse function? And so for the inverse function G inverse, to find that, we first switch X with Y. And put the letters in the right order. Switch X with Y, and then solve for Y. So we're going to have X equals the fifth root of Y. Now, remember, the fifth root is really the 1/5 power, right? So we get to play with rational exponents. And so if I switch that to the other side, that would be X to the fifth equals Y. So that means G inverse here, which my system here told me to call it F, is X to the fifth. All right, got that. So that's what goes here, X to the fifth power. And now I want to know, what's the derivative of that sucker? So F prime is just 5X to the fourth. So this is my 5X to the fourth. And then I'm asked to compose that with the inverse of the inverse. So what is F prime of the fifth root? And so that would just be a couple ways to write it. 5 fifth root of X goes in parentheses to the fourth power. And if we recall, the fifth root is the power 1/5, and we could rewrite this as 5 times X to the power 4/5. Would be another way to write it. Either one should be fine here. I should make sure I'm not lying about that. See what the instructions say. Check that just to be sure. Sometimes there's extra instructions when you click on the box. And it just says enter an algebraic expression and doesn't give us any restrictions. So yeah, we could enter it either way. Back to the notes. So I like the rational exponent rather than the radical form of this sucker. And then the last step is to just flip that. And so if I just write 1 over that F prime of F inverse, which is G of X here, that just gives me 1 over 5X to the 4/5. And that's my inverse function. Now here, I kind of like negative exponents. You might have had some algebra classes where they say, hey, rewrite this as positive exponents. Right? So I could say this is 1/5 times X to the negative 4/5 power to get that X out of the denominator. And either one is cool. Some days I like the negative exponents. Some days I like the positive version, but you got either way. So let's see, this would be, I'm going to go with my first version, my second version, 1/5 times X to the negative 4/5. And that is my derivative, 1/5 X to the negative 4/5. How could you check that? Well, you got a couple options. You could whip out that derivative calculator I showed the other day, which is a beautiful thing. Or you could graph a tangent line, see if that works out okay. Let's see, what else could I do to test this? We could cheat and use the power rule on that. So just check with the power rule for fun. So that would be G of X is equal to X to the 1/5 power. And if we assume the power rule applies, even though that's not a whole number, power rule says take the power down, keep the base, and then take 1 away from that power. 1/5 minus 1, well, 1 is 5/5. 1/5 minus 5/5 would be negative 4/5. And that's the same answer I got doing it the other way. So basically, the idea of the inverse function process for finding a derivative proves that the power rule applies to fractional powers also. Sweet. A new tool in our tool belt. Calculus stuff. All right, so type your answers in there carefully. Let's see what's next.